Okay, just to before we start, let me introduce the other instructors that will be teaching workshops today. So first is Michael. He'll be teaching today's workshop. So yeah, he raised his hand. Also there is Annie. He's going to be teaching the third workshop today, and the first is me. I'm Kosi, and I'm going to be teaching the second workshop today. So we're ready to start. Michael, you can go ahead and start presenting.
Sure. And everybody see my screen? Cool. All right, so welcome to Game Dev, everybody. You can check out the Slido link if you have any questions. Feel free to submit them at that link, or also feel free to put them in the chat, and one of the instructors should answer them if I don't. So we're going to be starting with workshop 1, which is a quick intro to game dev. We'll talk about our game engine that we're using, phaser.js. We'll also go over a quick review of JavaScript, and then we'll move on to populating our game with a background and also a player that you can control with your keyboard. So here's just a quick preview of the game we're going to be making. It's a platformer game where you will be collecting gears and avoiding enemies. So it's a 2D game, the gravity, and a bunch of physics that our game engine will handle. And in the future, tomorrow, when you start working on your projects, you'll be able to create games similar to this with realistic physics and also your own custom images and graphics and music and whatnot. So what is game dev? Game dev is making games, solving tricky problems, and combining math, physics, and design to create a fun experience for the user. And for this workshop, hopefully you guys have some code experience. I assume most of you guys have touched a computer and have written some lines of code, and we'll be working in JavaScript. You don't need to have some JavaScript experience because we'll be going over the basics in this workshop. And also, hopefully you guys know how to use a terminal because we'll be using that pretty briefly to create the project. And I'll explain some of the commands we'll be using. So in addition, I think you guys should have a code editor installed, such as Visual Studio Code, Git for version control and creating the project from our remote repository, Node.js to handle all your packages that you'll be using for the game, and also this tile map editor that won't be used in this workshop, but it'll be used in the second workshop. So let's go ahead and start with downloading the starter code. So I'm going to go ahead and also copy the repository name, and I'll put that in the chat. So what you guys want to do is type this command. So I just go into my terminal. I use CMD. It's on Windows. Some of the guys on Mac OS should have something called terminal. And so we type the command git clone. We paste in this URL. And let me just put that in the chat as well. If I execute this command, I should be able to have the project automatically created. And if you have any trouble with that, just type in the chat and have one of the instructors help you out. So I just cloned a repository, which means that I pulled from the internet this basically collection of code and brought it to my local computer. So if I go into this folder, you'll see that this folder was created just now. And so if I cd into it, which means I navigate in the terminal to that directory, so bp22 game dev, if I do tab complete, it should automatically complete the directory. And now you'll see I am currently in this directory. And then we'll go ahead and also type this command called npm install, which basically installs all the necessary packages being external code that other people have written that we might want to use in our project. So running npm install will try to install all those packages on our computer. This might take a while, so just let that run in the background. And of course, if you have any problems with this setup, just type in the chat and hopefully one of the instructors will tell you. What's up? Yeah, so for git clone, what you want to do, because I think some people had some questions. Basically, to start from the top, I would go into my terminal. I'm on Windows, so I type in CMD. I open up command prompt, and for the repository, let me post a link in the chat. This is the link of the repository. If you click on it, it should also bring you to this GitHub page. And so what you want to do, I first type git and then clone, and then I paste the link. And then I hit enter. Yeah, so I think the instructors are changing the privacy permissions right now, so hopefully that'll work. And I'll also just leave these commands on the screen for now. And I'll wait a few minutes so you guys can get that ready.
Also, if you have questions, it's easier for us to answer it if you ask on Slido. So the Slido link, again, I'm going to post it in the chat. If you ask questions there, it's much easier for us to reply to it. But yeah, we are working on the privacy issue right now with the repository. So we will change it from being private to public. So just wait for a second. Thank you.
Okay, in the meantime, I'll just type the commands that you'll be using in the Zoom chat. So one is git clone and cd bp. So that command will create the repository on your computer and it'll navigate you into that. Then you want to do npm install and then finally npm start. So hopefully when they change the repository settings, those commands will work. In the meantime, I'm just going to go ahead and do some JavaScript review. So JavaScript is a scripting language that's used on a lot of web applications. It's a very simple language. Some of you guys might already know it. I'll just go over some basic commands that are commonly used. So of course, for debugging, we want to print information to the programming console. And so in JavaScript, that's using something called console.log. And you can input whatever information you want to print out between the parentheses. In terms of commenting, this is similar to Java, where a double slash is a single line comment, and then a slash and a star is a multi-line comment. In addition, we have different ways to declare variables. You use the keyword let to declare variables that might change throughout the program. So for instance, let is today Saturday is true. We use let because it's not always Saturday, versus const, where we declare constant variables that will never change in their value. So pi, for instance, will always be 3.14, which is why we assign it to be a constant. In addition, JavaScript uses a lot of logic. So in terms of checking whether the value of a variable equals something, we can use the triple equality sign. So for instance, let house.size equals big. That checks if the house size value is big. The not equal equals checks if it's not that. So if the house.color is not blue, then that would evaluate to true. And of course, you can check these conditions in if-else statements and else if and else statements to determine the logic flow of your program. And we'll be using many of these throughout the game dev workshops. And finally, if you don't want to repeat a lot of code that runs many times, you can use something called a loop, of which there are a couple of types. A while loop depends on a condition. So for instance, you'll see in the image, while true basically runs forever because the condition is true here and that's always true. So other cases, you would want to do something while a variable is true or a condition is true. And so that's the use of a while loop, as opposed to a for loop where you're running the code a certain number of times. And you can see in the second example, for let I equals 0, I is less than 10, I plus plus, that essentially runs the console log up to 10. So it prints out the numbers 0 to 9. And then a for of loop essentially iterates through each element in a collection of things. So you'll see underneath the second for loop, underneath the first for loop is an array of types of cats. And then the final for loop just goes through every single cat and prints it out. So that's a for loop, just going through every element and printing the content. Finally, we have functions where we can put code into a kind of module that we might want to reuse. And functions are very useful because if we don't want to repeat code, we can just put that block of code inside something called a function. We can call that function, and it will call that code. We'll execute that code whenever we call a function. And this makes our code much more modular, makes it much more reusable, makes it much cleaner. And functions are tied to objects in certain cases, which makes it something called a method, in that whenever we create an object, which we'll talk about on the next slide, they have certain functions that are tied to their property type. So classes, which we'll be using a lot in this workshop, you can imagine they're kind of like templates to creating certain types of, they're templates to create objects, for lack of a better word. For instance, in the image, you can see class point. There are many different types of points because points can have different X and Y values, but all points share some commonalities, such as, they have an X and Y value, and they have this function that lets us, check the distance between the point and the origin. So instead of like hard coding a bunch of different points, we can just create this template for a point in this class declaration. Then every time we instantiate a point by calling new point, we can change the X and Y and quickly create many different instances of points with a few lines of code because we have defined this template before. And we'll be using a lot of these in the workshop, so hopefully it'll clear things up.
So before we move on, it seems like a lot of people are having trouble with either running git or like after they're either getting like a command that's like git is not recognized as an internal external command or something similar to that, or they're getting an issue that's like cd bp22-gamedev-starter.git is not working. So for anyone that's having those issues, the first one, so if you have like something that's like cd bp22-gamedev-starter.git is not working, instead type this command. So it's like similar to the command you were typing earlier, but it doesn't have the .git at the end. And that should make it work. That should help it start working. Yeah, the .git at the end is a typo. So other people are saying, why does it say git is not recognized as an internal external command? So if you have to install a program called git to actually use that command. If you don't have it installed, it was like recommended to install it before the workshop, but if you don't have it installed, there is a download link. Let me try to find it. That I'm gonna post in the chat right now. Yeah, so you can go there and install Git. It will take some time, but if you install that, then the command should start working.
Yeah, so I'm seeing some questions in the chat. In terms of what should happen after you install Git and you clone the repository, you should basically see all these words cloning into BP game dev starter, and then you'll notice that if you look at your terminal, you should see BP game dev starter in like this file path in your name, and you can also double check this in your, I think, Finder in Mac or File Explorer in Windows. You can go to wherever this directory is, so C users, and then Michael. And then you'll see, if you go through the files listed, you'll see that by running git clone, you have this folder created. And then I think the second question was, what is npm install? So when we're using phaser.js, there are a lot of code packages that are written by other people that we don't have on our computer. So running this command called npm install basically brings those external code packages to our computer. And this should run this type of output where we see the computer downloading all these packages, and it'll take a while, but you'll see the progress bar going up. And after that's done, we're basically ready with our environment set up. So hopefully those answer some of the command questions. If you have any more, just continue putting them in the Slido. And if you guys have any questions, I can also share the link of the slides. So I'll put those in the chat right now. If you guys ever fall behind, feel free to go to these slides and you should be able to take a look at all the content in the slides. Okay.
So if you ask questions on Slido right now, I just realized that we did not configure it properly. So you won't be able to we'll be able to reply to you, but you won't be able to reply to our replies back. So just for now, for this workshop, you should just ask questions in the chat. Yeah, sorry, we just said you shouldn't, but you should. We will try to fix the Slido. If we get it working again, we will go back to Slido. But yeah.
Cool. So just real quickly, let's go over some basics about the game engine we're going to be using. So we're using something called phaser.js, which is a JavaScript game engine that works in the browser. The advantage of a game engine is that it's very hard to replicate the physics of the real world. It requires a lot of math that a lot of us don't really have the time to learn. So using a game engine such as Phaser helps us handle these common game dev features like physics, graphics, and user controls. And so this makes it easier for us to develop the game because we don't have to worry about all these low-level implementations. In addition, Phaser is free, it's open source, so you don't have to pay any money for it. So how does it work? Generally, Phaser is organized into scenes, which every scene represents kind of like a game state with a UI, levels, and menus. Basically, any game setting that has different objects in it. So for instance, different levels, each level might be a different scene with different characters, with different enemies, with different players. So the phaser.js scene is an actual like coding object, which we'll go over once we start coding. It has three main functions. One of them is called preload, and this basically loads all the images and assets. So you can imagine music, graphics, etc. It loads them into the game so that they can be used throughout the program. Create initializes all our objects. So you'll see us eventually creating backgrounds, players. We'll be creating those and their respective properties inside this create function. Destroy cleans up these objects so that when they're not being used, we don't eat up our memory. And finally, the game loop is essentially how the game works. It's the flow of the game once we're playing it. Basically, the game first processes the user input, so keyboard, mouse control, then updates the game based on those inputs, so changing the physics, moving the player, changing the enemy movement. Then we render all these changes, and then we repeat the loop. So when we go into the code, you'll see there's a function called update that will run through all these three things and thus change your game based on the user's input. So I think once you guys have cloned the project, hopefully some of you guys have done that successfully, you'll notice a bunch of files. And so I'll open up VS Code right now. And basically, there are a bunch of different directories and files inside this project that we made you open. Let me just go ahead and open up the project. So I'll click File, Open Folder, and I'll click on the code I just cloned. And you'll see a bunch of these things. Most of these are pretty useless for our purposes. I'll just point out the ones that might be important. So index.html, that's like the actual page that our game will be loaded onto. And so if you want to change what the web page looks like, you can modify this. Package.json and package.lock.json, those you won't really need to edit, but they just list all the packages or external code dependencies that our project relies on. And the really important things are in this folder called source, src. And we have index.js, which basically configures our game. We'll be putting all our graphics and images inside this assets folder. And in addition, we'll create our scenes here in the scenes folder, and all our components such as players, enemies, collectibles, all of those will go in components. Yeah, so you don't have to install VS Code if you have another code editor, but if you don't have a code editor, we highly recommend downloading VS Code. Okay. Cool. I'll pause here to just wait if there are any other questions and anything I need to go over again. Okay, so there was a question on how I opened up VS Code and what I did. So basically, to walk you through it, I go into, for Windows, I just go to the Windows home key and type in VS Code, and it opens up Visual Studio Code. And then in terms of opening the folder, so I cloned it to this location. I did get clone. You'll see it's in users, Dropbox, college, etc. So I click on file, I click open folder, and you want to make sure you click open folder so that you get this nice kind of like file structure organization on the side. So click on open folder, file, open folder, and then maybe it'll like move you here. And so since it says it's in users, Michael, Dropbox, college, I'll go over to users, Michael, Dropbox, college, etc. And I'm basically just navigating to where the repository should be. So since game dev starter is in all this directory path stuff, I'll open it up. I'll click it once, and then I'll click select folder. And in terms of what you're supposed to open in VS Code, you want to open the folder called BP Game Dev Starter. And then, yeah, once you open it up, you should see all this stuff on the side, specifically like the source folder. That's all where all the important stuff is. right, so I think we have some people that have been able to open everything up. We're gonna go ahead and start live coding now. If you have any questions, just feel free to continue pinging the chat, and then Kosi and Annie will help you guys out. So we'll first start with making a background. And so
So I'm going to make a poll right now to see how many people are still having trouble getting set up. So if you can, please answer the poll. It's just going to be a yes or no poll. Okay, so what we'll do now is there's still a lot of people having trouble get set up. So what we're going to do now is we're going to, because all the code will be on the slides, and Michael will do it live and it will be available to you. So what we're going to do right now is we're just going to go through it and like code. You don't necessarily have to follow along. And then after Michael is done with that, hopefully between workshops, anyone that's still having trouble, we can help. So yeah, hopefully that works out. Sorry, yeah, it's I think the information wasn't communicated very well, but we kind of expected a lot of the stuff to be installed beforehand. But like if you're installing it as the workshop is going on, it's kind of difficult, and we totally understand. So after that, just stay in the Zoom room, and we will help. We will like show how to solve some of the common ones, hopefully. So yeah, I think we're just gonna go forward. But if it's like an easy question you can ask, yeah, just ask it in the chat, and we will try to answer. So thank you all.
okay, cool. So we're gonna start with some V coding. All the code will be put on the GitHub. So if you don't follow along, feel free to check the GitHub page. And of course, I'll just put that in the chat as well. Okay, so to start off, I have the code editor open, and we'll go through, let's just walk through index.js, which, as I said, is an important file that basically contains this object called config. And this contains all the configuration information about our game. You don't really have to worry about it since we gave it to you. Just some things to point out. You can change your game height and width here. So the actual size of the game will, in the browser, will change here. The physics mode, we usually choose default as arcade. But if you guys want to maybe make some more high fidelity games that actually use real world physics, you can change this to like other options such as I think matter or is one of the other options. And then the gravity is set here in the y direction. And this is like 300 units per, I believe, 300 units of gravity. And now, in addition, we have this variable called debug. Right now it's set to false, but if you set it to true, it'll draw hitboxes around the game objects so that you can see when things are colliding. And finally, we list all our game scenes in this scene property called scene. And we put any game scene we created inside this array, and we'll next go to that game scene file. Next folder you want to open up is main scene.js. And you'll see here, this is where we see the organization of phaser. into different scenes. We'll be working in main scene right now, where you'll see we have the functions I mentioned before, preload to load all the assets, create to initialize all the game objects, and update to do the main game loop I talked about in terms of getting user controls, updating the game, and rendering everything. So let's go ahead and move on to loading our first image. So basically, all our assets or images in our folder are in source assets. And you'll see we have this thing called sky.png. This is basically the backdrop for our game. What you want to do is import it using this command called import. And then the next phrase is called, the next one is what we'll call our image. So we'll call it background image. And this will basically create a variable called background images, which points to the location of our sky image. So assets, images, sky.png, or background.png, sorry. So this is the background we want to use. And so by using this path, this basically means that we're currently in the scenes folder, but we want to go back one. So if you look at the file structure, we want to get out of scenes, we want to go into assets, and these two dots means that we're going out of scenes, and we're going into assets. And then inside assets, we're going into images, and then we're going into background.png. So that's kind of an explanation of why we use this particular text. So after we import this background images, we can go ahead and use this command called this.load image. And then what we want to put in next is kind of like the name of the image we're loading, and also the image variable we created up here. So you can copy and paste that, put that in here. And this will basically load the image from that file, and then we'll give it a name of background. The next thing we want to do is create a background component. And basically we'll go into components, make sure you highlight the folder and right click it and click new file. And we'll call it background.js. And why are we doing this? So we want to create modular code that uses the classes I mentioned before. And so by creating a new background, you can imagine in the future when we have different backgrounds, we can reuse this code in background.js to create many different backgrounds instead of repeating the code over and over again. And inside this background.js, we need to first import phaser. And then we want to type out these lines, export default class background. And so this basically creates a class called background. And then when we use this word called extends, this means that it's a subclass of game objects.image. What is a subclass? This essentially means that whoever wrote the code base for phaser created this image class. And when we use extends, we create an object that's basically very similar to image, but has some extra properties that we want to add. And this is kind of like inheritance, if you guys have heard of it before, where background is a subclass of phaser image. And they'll share a lot of properties, but there will be some differences in our subclass called background. So next we want to invoke the constructor for our class. And this basically is a method that is called when you create an instance of background. And then we'll go ahead and use this word called super. And then we'll call scene 0, 0. And we'll finally type in background. What this basically does is that super calls the constructor of our class that we inherited from. So this will call the constructor for phaser image, and it'll pass in these properties. Background being like the name of our background. And then we'll go ahead and do scene.add.existing this, which basically populates our game scene with this background. And finally, we'll set the origin to 0, 0. Okay, so hopefully you guys have everything there. Go back to main scene. And now that we've created our background class, we're going to go ahead and import the background class. This is different from importing the image. So before we imported the actual image file, now we're importing this JavaScript code. So we'll type import background, and we use this word because this matches the name of the class. Import background from, and of course, the next part of code is the file path. So we'll go out from scene and we'll go into components and we'll go to background. Now we have our background class inside main scene.js. We can go ahead and create it inside this create function. We'll do const background equals new background. And using the new keyword just indicates that we're creating an instance of background. We're creating a specific object that is of the type background. Okay. And I think now that we have that, we want to go back to our terminal and make sure we're in the BP game dev starter. If you run npm start, this should start our game in the browser. I'm going to go ahead and wait for that to run. You'll see all this stuff get inputted out, and it'll automatically open a new tab with the URL localhost 8080. And it'll take some time, but eventually once it loads, you'll see this black screen and you'll see the image loaded. Yep, so the command to start it, I'll put that in the chat. You want to run npm start. Yep, because you already got it. So just to show it again, I'm in the thingy. I'll run npm and then start. And that basically just generates like this web server that starts hosting the game. So hopefully you guys start seeing things. And yep, I'll go back to background.js for a few seconds. Yeah, of course, if you guys need to verify the code, you guys can check the GitHub page at here. And of course, we'll go over it again probably in the future. But yeah, not too much code for this first part. Hopefully you guys have this nice background loaded.
Okay, so Michael is very experienced with programming, so he does type a little fast, and it does kind of feel like someone mentioned, like a typing test. It's totally okay if you can't type and keep up. In fact, I don't think I would be able to if I was just watching Michael. So essentially what's okay is we'll just watch Michael code, and then there'll be a command we can run to just like get all the code that Michael has just typed. Especially because it just feels like we're kind of competing with him and like the speed he's typing. So just watch along, and then the next we'll be like running commands periodically to basically download the thing that like was just said in the workshop, and we'll make sure like everyone can do that, and they'll be able to get the stuff up and running. So yeah, that's just like a quick side note. I noticed that. So yeah.
Okay, so sure. Now that we have the background in, let's go ahead and start to load in our player. Okay, so just in case you guys want to catch up real quick, in the terminal, if you want to get to the same spot that I am at instantly, you can run this command called git checkout, or So you want to run this command called git checkout and then o1 dash making a background. I think that should load all the code. That should load all the code necessary for the next part. Okay, so I'm going to go ahead and continue with the thing. Let's go on to creating our player. So we'll first go back into main scene.js, and we want to start importing all the assets we're going to be using. So underneath background image, we'll type in import, and then we'll go import something called a player sheet from this directory. So it's in assets. We'll go to sprites this time. We'll go to player, and then we'll go to sheet.png. And if you go into this folder, you'll see under sprites, we have this thing called player. And we'll open up sheet.png, and you'll see something called a sprite sheet, which is basically a large image containing a bunch of smaller sub images. And essentially, this means that when we want to use an object that is animated, we can load this image, and instead of loading many different images for each animation state, we can just partition this image such that if you want to animate it, we'll just maybe take this section, then take this section, then take this section. So we don't have to import that many images. The next thing we'll import is something called player atlas. So we'll call it player atlas. And this is essentially like a little file that contains all the information about our sprite sheet. So it's an assets, sprites, player, and then it's called atlas.json. And if I open it up, you'll see it's just a bunch of text, specifically JSON formatted text, that contains a bunch of information about our sprite. You don't really have to worry about it for now, but just know that it contains information about our sprite sheet that we're going to be using for our player. Okay, so next we want to load this stuff. So we'll do this.load.atlas, and then we'll do player. And the next two things we want to import are the player sheet image. So we'll use player sheet, and then in addition, we'll do player atlas. And this command essentially loads in a sprite sheet. A sprite sheet is also synonymous with an atlas. And so we want to put in the player image. We want to put in the player image information file, which is the atlas file, and we want to call it player. So now that we have that, let us go ahead and create a new class. So click on components, make sure it's highlighted, right click, click new file, and then we'll call it player.js. Okay. And now that we have player.js, we will go ahead and create our class for our player. We'll do import phaser from phaser. We'll do const base speed. And these will be like general properties for our player. So we want them to move at a speed of 200, and we want their height to be 64. And we're using this const variable so that these properties can never be changed in the code. Next, we want to do export default class player extends phaser.physics.arcade.sprite. What this means is that we're creating a class called player, and this class is going to be a subclass of an existing phaser class called sprite, so that we have some of the properties of sprite, but we can also add our own properties to player. And then we'll first invoke the constructor so that anytime we create a new player, it calls this function. We want to pass in the game scene, and we want to pass in the X and the Y coordinates for where our player will be. And then we will go back and click and type in super to invoke the constructor of our parent object. We'll do X, we'll do Y, and then we'll also pass in the name player. And then of course, we'll add the actual player object to the game scene using this command. And then we'll also need to add the player to the physics engine using this command so that we can actually apply physics to our player in the game. So next, we're going to create these two methods. So go down a bit, and then we'll do create properties. And then we'll also create a function called create animations. So inside these methods, we're going to populate them with some information about our player. For create properties, we'll use these 3 lines. So set, collide, world bounds. And we'll set that to true. Basically, this means that if our player runs into like the borders of our game, they won't go off the screen. Next, we want to scale up the player. So this dot set scale, and we'll pass in 1.2 so that our player is, I guess, 1.2 times bigger than what it would be. And finally, since we want to use physics, do this dot body dot set allow gravity equal to false. For now, we don't want to put in gravity for testing, so we'll just set that to false. Okay, next we're gonna do this weird thing called this dot create animation. So we'll do this dot anims dot create, and then you want to put in parentheses and then curly braces. Essentially, what this function is going to do is that it's going to configure the player so that we can use animations for the sprite sheet. So let's say when we create, eventually when we move the player around, it'll display like a walking animation. So for now, we'll just do, we'll define the key for the animation as player idle. Then we want to type in frames. And this will basically generate all the frames in our animation. And we'll use this thing called this.generate frames. And then we'll pass in player. And then we'll pass in this object where the prefix of the image will be player. The suffix of the image will be .png. The 0 pad will be 2. And then the frames will be 5. And this is basically just information that points to our sheet so that we can partition it appropriately so that we get the correct image displaying at the animation. Then we'll also set the frame rate to 20. Okay. Now, for the other stuff, we kind of want to create a bit more animation. So do this dot anims dot create. It might be faster to just copy paste this. So if I just copy and paste that block of code, and let me just show that again. I'm selecting all this, copy pasting, and then I'll put it there. And then this time we want to change it to player left. We want to keep it as player. Keep everything else, but change the start to 1. And the frames to, we want to change out frames for start. And we'll change that to 1. We'll add a property called end and 4. And that basically, again, tells us how to partition our sprite sheet. Okay. And then we'll set the frame rate to 0 and the repeat to -1. All right. So the last one, we can just copy and paste this player left. And then instead of this being the left animation, we'll make it the right animation. So we'll change that to right. And in addition, we'll change the start to 6. We'll change the end to 9. And then we'll change the frame rate to Oh, instead of the frame rate being 0, make sure it's 8. It's a typo on my end. So make sure both of these frame rates here and also here are 8. And we'll keep the repeat as -1. Okay, so now that we've created these functions, we can call them in our constructor. And basically, we'll do this dot create animations, and then this dot create properties. And then this will basically create the properties for a player with all these physics configurations, and also it'll create all the animations for our sprite sheet so that we can use them later. And then next we want to do the display size adjustment. So we'll define this thing called aspect ratio, which is basically the width of the player and divided by the height of the player. And then we'll set the display size of the player appropriately. Since we want the player to not look squished, we'll do the aspect ratio times the height, and then we'll put in the height. So basically, this is the width, and this is our height. And so we basically scaled our player perfectly. And finally, we want to animate the player with the default player idle animation we defined down here. Okay, so that's all for our constructor. We're going to go ahead and create the last method. So go down a bit and let's create this function called update. This function takes in an object called cursors. I'll explain what that means in a bit. Basically, cursors are the key commands that are passed in. So for instance, if I want to detect if the left key is pressed, I'll do cursors dot left dot is down. And then if that's true, let's set our velocity. So we'll move the player to the left by setting the velocity x to the negative of the base speed. Meaning that if we press the left key, we'll move the player to the left with a negative velocity. Otherwise, if the cursor's right is down, then we'll do the velocity x to the positive of base speed. Otherwise, we'll just set the velocity x to 0. Okay, almost done. Now let's just do it quickly for our up movement. If the cursors dot up dot is down, then we'll set the velocity y to negative base speed. So this time, if we press the up arrow, our player will be moving up with a negative velocity. Otherwise, if the down arrow is pressed, so cursor dot down is down, we'll set the velocity y to base speed. Otherwise, again, we'll set the y velocity to 0 because our player isn't moving because there are no keyboard commands. Okay, so that's our entire player class. Now that we've created the template for a game player, we'll go ahead and go to main scene and we'll actually call it. So let's go ahead and create our player in the create method. We'll go ahead and do, we'll define our x equal to the camera main center x, which essentially is the center of the board, the game board. And then this dot cameras dot main dot center y. And then this dot player equals new player. X and y being the center of the game. This is just a command to invoke it. So we'll call the player constructor, we'll pass in this game scene, we'll pass in the x, we'll pass in the y. And then finally, for update, we'll call the player's update function. And before we do that, let's also create the cursors. We'll type in this.cursors equal this.input.keyboard.create cursor keys. What this means is that we're going to take in the inputs from the keyboard, and we'll create an object that will pass into the player's update function. And now I believe that's everything. Once we have all this stuff created, we created a new player here. We defined its X and Y to be the center. We created a variable that takes in the keyboard commands, and then we pass it to the player so we can update them with these keyboard keys. And then using these keyboard keys, we will basically set the player speeds based on what key is pressed. And if we go back to our game, and we do npm start again to start the game, execute that command. And this will run in a bit. And we'll let that load open. Yeah, I know this is a lot of information. If you guys have any questions, make sure to put them in the chat, and then we'll probably feel free to reach out to us on Discord. We can go over everything. So this is running. It's on localhost 8080. So if I refresh the page, then this eventually should load. Okay, let's see. All right, so before this can work, I also need to import the player object. So make sure you import the player class from the respective directory. So components, and then player. And then if I refresh the page, hopefully there are no more other bugs, but we'll just patch up some errors that might occur. So yeah, basically what happened is you need to make sure that you import the player objects like we did for background. And in addition, yes, let me point out there are some errors with the frame rate code. So let me fix that up real quick. So actually, yeah, we want to move this frame rate to outside the parentheses. That's a good catch. And then also the same thing with the frame rate and repeat. We'll move those outside so that it's underneath the curved parentheses instead of the curly braces. And then now that's up, you'll see our player is there. Another bug, this.generate frames. Generate frames should be generate frame names instead of generate frames. So there's a typo there. So generate frames should be generate frame names. And then if you go back here, we'll reload. And oh, stop, hold on. It should be this.anims. Yep, so yeah, just another typo, sorry. Make sure it's generate frame names instead of generate frames names. Yeah, that's what I'm doing. Okay. Let me just refresh the page. Okay. And now we have our player moving out and about through the keyboard commands. Yeah, sorry, there are a lot of typos. Basically, make sure you use this .anims .generate frame names. I had a couple of spelling mistakes there. So if you have any questions, make sure you put them in the chat. I think okay. So we're gonna cut the first workshop there since we went over a bit, but we're also gonna stay online to answer any questions you guys have. So I guess feel free to put them in the chat.